Hello and welcome back. This video will start section 1.7, which is all about inequalities. And in order to really discuss inequalities, it'll be helpful to have some notation, and we'll look at intervals. And intervals are essentially just a part of the real line, and we have a lot of different types of intervals, so we'll go through each one fairly carefully. So this is what's called an open interval. And we denote this with parentheses around a comma b. In here, I really want a to be less than b. So a is going to be some number that's less than b. And when I write the open interval ab, maybe I can do this in red, what I mean is all of the numbers between a and b. So it's all of the numbers between a and b. One way to write this is that if x were inside of the set, x would have to be between a and b, meaning x is going to be less than a, but greater than b. So in set notation, this is going to be the set of all x, such that this condition is satisfied. So it's going to be any x, such that x is between a and b. Greater than a, but less than b. When we use closed, or when we're talking about a closed interval and we're using square brackets instead of parentheses, this means that any element in here is actually going to be less than or equal to b, and less than or equal to a. And we can denote this with these closed, with these square brackets here, but essentially when we have these square brackets, we mean we're going to include the endpoints. So a is inside of this set. So a itself is inside of here. But in this set, a is not in here. So the difference between these sets is whether or not the endpoints are included. For an open interval with parentheses, we stop just before a and b. In here, we include both a and b. And again, this will be the set of all x that satisfies a is less than or equal to x, which is less than or equal to b. Now, we can mix and match these as well. So we can talk about half open and half closed intervals. So here, this is going to be the set of all x, such that we have a parenthesis on the a, so we're not going to include a, but we have a square bracket on the b, so we are going to include b. So x could be less than or equal to b. The or equal to is what makes the difference here. So again, we don't include a, but we do include b, and everything in between. Likewise, if we have the square bracket on a and a parenthesis on b, we will include a and not include b. So again, this interval will be everything greater than or equal to a, but less than b, strictly less than b, and not including b. Now, we could extend these intervals forever going in a direction, so we get some infinite intervals as well. And the notation for these is fairly similar. You can either have a parenthesis on a, meaning that we're not going to include a, or we can have a square bracket on a, which means that we will include a. But when we write infinity on that side, it means we're just never going to stop. Notice that the parenthesis here means that we're not going to include infinity, because infinity is not a number. We don't include it inside of the interval. It is always a parenthesis on infinity. So in this case, we're not going to include a, but we're going to include everything bigger than a. Here we are going to include a and everything bigger than a. So again, with the set notation, this is going to be everything that's bigger than a, not including a. So anything that's bigger than a. So it's all of the x's that are bigger than a. Whereas in this case, it's everything bigger than a, or a itself, because we want to include a. So we have less than or equal to. In this case, we put the infinity on the other side, which means that this is going to be everything less than b. So this is going to be stretching down. And again, with a parenthesis, it means we're not going to include b, but we're going to include everything to the left of it. With this negative infinity, we're just going to go down forever. Or again, with this the square bracket, meaning that we're going to include b and everything less than it. So here, this set will be the set of all x's that are less than b, and that's it. Here, this will be the set of all x that are less than b, or it could be equal to b, because we want to include this in the set. So this is the notation for intervals. Hopefully this is fairly clear, but we can do a couple more examples as well. And again, the one thing to remember, parentheses and square brackets. Parentheses do not include the endpoints, but square brackets do include them. So here I have three number lines. I've got from -4 to 5 on the number line itself, although the number line will continue forever in both directions. And let's do a couple of these intervals. So let's do this first one. So I'll call this number 1. This is going from -2 to 5. We're going to include -2 because we have a square bracket, and it's going to go up to 5, but not include 5. So it'll be everything between. Likewise, for interval number 2, this is going to start at 1 and end at 3.5, but we have square brackets on both sides, meaning that we will include 1 and 3.5. So 1 will be right here. 3.5 will be a little bit bigger than 3, but certainly less than 4, so it'll be everything in here. And then with this one, we have the interval from -infinity up to -1, but not including -1 because it is a parenthesis. So starting at -1, we will go everything below -1 forever because we have that negative infinity. So here we can start to build some of these graphs on these number lines. And the one thing that we'll do with these first is look at their intersections and their unions. So intersections are the elements that are going to be in both sets at the same time, as in it's where the two sets overlap. Whereas the union, we're going to put the sets together into one big set. And again, maybe a more precise way of saying this is that the intersection is going to be each of those elements, each of the numbers that are common to both sets, as in they're in both sets at the same time. Whereas the union, we're going to take everything in A and everything in B and put them together, as in we're going to make a big set of elements. It's all the elements in A, together with all the elements in B, together with all the elements that are in both A and B. So again, we can do a quick example. So here, this is the intersection symbol. So intersection is this upside down U shape, and then the union is this U shape, although it's not quite a U. So here we have the intersection of two intervals. I'm going to put the first interval in red and the second interval in blue. I hope this shows up. And the first interval goes from 1 to 3, and both endpoints are square brackets, meaning that we'll include both 1 and 3. The second interval is from 2 to 6, not including 2, and not including 6. So what we want is the intersection. So we want where these intervals overlap, And we can see that they will overlap from 2 to 3. Okay. So this much is clear. However, the question is, do we include 3 or do we include 2? Which ones do we include and not include? Well, because 2 is not included in this set, it can't be in the intersection. But since 3 is both in the set on the left and in the set on the right, it is included there. So our interval will be from 2 to 3, not including 2 because it's not in here, but it is including 3 because 3 is in this set. And then for the last one, let's look at the union. So again, we have the same two sets, the set of numbers from 1 to 3, including 1 and including 3, and the set of numbers from 2 to 6, not including 2, but including 6. The union is going to be putting both intervals together, combining them into one big interval, and we can see that this interval will include 1. I haven't lined this up right, but it'll include 1, and it'll include all the numbers up to 6. If we're taking the union of these two sets, it'll include everything in both sets. So there it is. And it's so we're going from 1 up to 6, and again, we're including 1 because 1 is included in this set. And over here, we're including, excuse me, we're not including 6. Yeah, I made a mistake here, didn't I? So we're not including 6. Because in this set, this has a parenthesis there, so it means that we're not including 6. Phew, we fixed that. And this is just a brief introduction to intervals, which we'll use throughout this section to make writing down the answers to these inequalities a lot easier.